All right, today we are going to talk about how we compare different distributions, focusing on dot plots, stem plots, and histograms. This is stuff that you already kind of know, but just elevating it one level. So the first thing on your notes says, what is the most important thing to remember when you're asked to compare two distributions? And really, there's two things. We are still going to be using, whenever we talk about a distribution, you should be thinking about the shape, unusual feature, center. Oh no, I said shape twice. This is spread. Spread, spread. And it's important that you actually explicitly compare them. So don't just say what the spread or shape of distribution A and B are. Make sure that you compare them. So, I would say that distribution A is more spread out than distribution B, or the center of A is greater than the center of B. So making sure that you explicitly discuss whatever the comparison is. So that's the first one, and I will do an example. So it says the dot plots below represent the energy cost of refrigerators with freezers on the top compared to freezers on the bottom. How do the annual energy costs compare? Tells you where the data is. Compare these two distributions. So just when you look at these right away, there's a lot of things that you should pick up on very quickly, and you should do that by making sure that you include those 4 core elements that we talked about. So I did it in bullet points here. So make sure that you always use the context. So I'm saying the typical energy costs for bottom freezers. And then if you want to give yourself an abbreviation, just make sure you define it. Is greater than top freezers with medians around 70 and 56 respectively. So the median of the bottom is kind of around here. The median of this one is down here. Obviously, we're not going to sit here and be able to calculate the mean. So we're just estimating the center by looking at where we see the median. So that was our center. The next one that I wrote about here was unusual features. So there appears to be high outliers with bottom freezers. There's no outliers for top freezers. There's much more variability. So variability is a word that we will use a lot more later this year, but it's a way to say spread. But you could have also just said the bottom freezers are much more spread out than top freezers, but we're talking about the spread here. And then the bottom freezers distribution is definitely skewed to the right. And it's important to use things like possibly or roughly because we don't want to say things are exact with what we're talking about right now. Well, we just say where it looks like this, it could be this. So if you didn't include this possibly bimodal, it's okay, but it does kind of look bimodal. Like here's kind of one, and then here's the other. So possibly bimodal, but if you just said skewed to the right, that's fine. Well, top freezers look roughly symmetric, so it's not perfect symmetry, but it is roughly symmetric, and unimodal. There's just kind of one hump over here. Okay, so to compare the distributions, it's important that you include the context of the problem. So you cannot just say like, the bottom is skewed to the right, the top is skewed or is roughly symmetric. Making sure that you talk about the context and that you talk about shape, unusual features, spread, and shape, unusual features, center, and spread. Okay. All right. And I'm just going to ask you to do these 2 problems in your notes, or this one problem. So you should be able to compare. So it says the dot plots below represents the distance of projectiles from 2 catapults. So there are the 2 catapults, A and B. So you should compare them, making sure that you include the words catapult, and, talk about the spread. This one is larger than this one. Talk about the center. I think this, center looks greater than this center. Talk about the shape. What do you see for shape? And then talk about unusual features. So that's what you're doing for A. For B, it says there is a target that is 5 centimeters wide. If you want to maximize the probability that a projectile lands within that target, which catapult should you use and why? So you should definitely use catapult B, right? It's more consistent. Then it asks, if you're using catapult B, where should your target be centered? Well, your target should be centered where you have, so it's 5 cms, where you have the most amount of data points. So, probably around here. Okay, so answer this question fully. I kind of talked through it, and that's all you need to do. I hope you have a lovely weekend.